So there's some things with this that you need to always remember, that if you had that, that's the same as having that. It's just an unknown number.
Yeah.
And so if that equals, if this equals 4 to the power of 1, 2, 3, 4, then this likewise is going to be to the power of 4. Yeah. So if you had x squared times x, if we expand that out, that's x times x, because it's x squared, it's x times itself. And then we've got to times this by x. Again, you're just multiplying the same thing together, and it can be to the power of however many there are. So when you're looking at something like this, you use foil, don't you? Yep. All it's a matter of doing is multiplying this by everything in here, and then this by everything that's in here, and then this by everything that's in here, and just adding them all together. Alright, but remember that we are, and I think you're forgetting that sometimes, that it's a multiplication sign in there. Okay? So if we had, our first thing is 5x squared times 2x. Okay? 5x squared times 2x. So we do the numbers, 5 times 2. And then we're doing x squared times by x. X squared looks like that, times by x, therefore gives you x cubed. Alright? All these steps aren't new to you, you've done them before. It's just a matter of putting them together. So it's x cubed there. Yeah? So then you multiply 5x squared by what now? By minus 3. Good girl. 5 times minus 3 is minus 15. And we've got x squared. Okay? So then it's negative x times by 2x. And x times x is, yes, there's a 1 in here, and negative 1 times positive 2 becomes negative 2x squared. Okay? Negative x times by negative 3 gives us 3x. Yeah? And then 2 times 2x gives us 4x. Yeah? And 2 times negative 3 gives us negative 6. Alright? So step 1 is to try and follow what you've always known and done. Like terms, like terms. Like terms, like terms. The rest aren't, are they? So it's a matter of 10x cubed, and there's no other x cubes there, that's why there's no like terms. Negative 15x squared take 2x squared is minus 17x squared. Good girl. Plus 7x, good. Take 6 remains the same. We can't simplify that any further. Okay? So remember that when you had a take b all squared, it went square the first one, take 2 times a times b, plus square the last one. Yeah. Alright. So if you had, what is it by the way? 3 take x, is it?
Yeah, 3 take x.
When it's 3 take x all squared, then you're squaring the first one. Take 2 remains constant for every one of these formulas, times by 3 times by x plus x squared. And so you've got 9 take 6x plus x squared. Alright, and again you can check that by saying try and do probably is it's 3x take squared, take x all squared, and then what's the other one alongside it? In that question, what does that question look like? Sorry.
Yeah, just the other one is plus x take 3 squared also.
Plus x take 3 all squared. Yep.
Yeah.
Yep. Plus x take 3 all squared. You probably do the same out here. I'd put a plus in there and then have do that process all through there.
Yeah.
Then that plus is going to affect some of those numbers in there.
Yeah.
Sorry, those signs, and then try and collect like terms altogether.
Yeah.
All right. That's page 450, isn't it, Mark?
Yeah. 455.
So. This is the only unknown. Okay, that's the only unknown there. And so what you're trying to do is you are, in the first instance, you're trying to find what the Fahrenheit is, given that the Celsius is 36 degrees. 38, sorry. 38 degrees. Okay, so we bring up our calculator. It's 9 divided by 5, and that remains constant. So it's always really 1.8 times by the degrees Celsius plus 32. So at 38 degrees, it's around 100.4 degrees Fahrenheit. And then they're asking you, if you make C the subject, so if you grab the formula being that and rearrange it so that C comes out here and F goes over there, then what you did here, you went from degrees Celsius to degrees Fahrenheit. And what this one will do, once you create a new formula here, you'll be going from degrees Fahrenheit to degrees Celsius. Okay, so that's not much different to what we've been doing. It's just you're moving an unknown, and sometimes that can throw us when we're moving an unknown and not a number. All right, is that okay?